everyone. This is lesson 113 in Simple Solutions. I'm going to start off with problem number 1. It says there were 75 people on a train. At the first stop, 12 people got off. At the second stop, 28 people got off. How many people were still on the train? Okay, I know my total. There were 75 people on a train. And I know at the first stop, 12 people got off. And in the second stop, 28 people got off. Now, I have to think about, is this going to be multiplication problem, division, addition, or subtraction? Well, I know that we have a total, which is 75, and if 12 people got off, I would take away 12 from 75, because the problem wants us to know how many people were still on the train. So I'm going to be subtracting to find out how many people were still on that train. But I start with 12, and then I would take away 28. So 75 take away 12, 5 take away 2 is 3, and 7 take away 1 is 6. So now I have 63, but I'm not done yet because I need to take away 28 people, because at the second stop 28 people got off. It's 28. I can't do this. I need to borrow. This becomes a 5. This is now 13, take away 8, 8, 9, 10, 11, 12, 13. Should be 5. 5 take away 2 is 3. So this would be my answer. 35 people were still on the train. Number 2, 322 plus 217. Number 3, 7 times 7. If I needed help with multiplication, I could draw a picture, because that would help me. I could draw an array, I could draw groups. Number 4, 603 take away 278. Now I'm just going through these quickly because I know the majority of us know them. But if you still need help, let me know. Number 5, write 54 tens and 6 ones as a base 10 number. Okay, I know that I have 54 tens, and I know that if I add a 0, so if I add 54 tens, I have a total of 540. But wait a minute, it says and 6 ones. So I would add 6 ones to my ones place. So the answer would be 546. Okay. Number 6. Turn to page 297 of your hands-on pages. Measure the pencil, match, popsicle stick, key, and paper clip to the nearest ½ inch. Use X's to add the data to the line plot. This is another one that we've seen in the past, and I mentioned before, if you don't have a ruler, that's okay, don't worry about it, you could just skip it for now. Number 7, 56 divided by 8. Now I can find the inverse operation, which means I can flip this around. 8 times something equals 56. Sometimes when you look at multiplication, it's easier to solve the division problems. But if I didn't know my 8s, I could always do equal groups. 8. Find the perimeter of the hexagon to the right. Finding the perimeter, that's the key word here. And perimeter means to add up all the sides. And each side of this hexagon is 9 meters. So I'd have to add up all the 9s. 9. Round 82 to the nearest 10. So if I'm rounding to the nearest 10, I look at my ones place. Is it less than or greater than 5? If it's less than 5, I round down. If it's more than 5, I would round up. 30 times 9. 11. Which picture shows 24 divided into 4 equal groups? So I'm looking for the picture that has 24 divided into 4 equal groups. That means in each group there should be 4. Okay. Or in this case, it might be, yeah, it's each group has 4 in each group. And I already see this one here has 6, and this one has 4. Now if I pick this one to check my answer, I should have 24 as my total. I can count up each dot, and when I count them up, they should equal 24 as a whole total. 12. Count by 5s. 45, 50, and so on. I think most of us know how to count by our 5s, so I'm just going to skip that one. 13. Label the point half of the way between 0 and 1 with the fraction half. So looking at a number line, all they want me to do is to label this missing part as half. So I'm going to put that in here, which makes sense because when we look at the number line, this point right here is half of this number line. 14. What fraction is shaded? Fill in the missing denominator. So I'm looking at my denominator, which is the number at the bottom of my fraction. The 10 should represent how many I have shaded. So the number at the bottom, the denominator, should represent my total. So I would count up all the sailboats and put that answer in my denominator space. 15. It says whole numbers can be written as fractions. 4 is equal to 4 over 1, and 6 over 1 is equal to 6. Okay. Write the whole number 5 as a fraction. So, just looking at this example, if I have a whole number and it is 5, I'm going to have 5 over 1, because 5 over 1 is equal to 5. Alright, that's it for this lesson. Please feel free to tune in to the next lesson when I begin lesson 114.